Okay, great. So again, this is the class website. If you don't have that down already, you should have your login information through your emails and stuff like that. Okay, so this is Stats XL10, and pretty much intro statistics. Okay. Anyone? I'm just curious. Anyone already have their bachelor's degree? Okay, a few of you. All right. Okay, but a lot of you are looking to transfer. Oh, so actually, I'm going to pause the video here for a brief second. Well, I'll go ahead and say it on the video. Some of you already have your bachelor's degree and are applying to graduate programs, and maybe you've taken calculus when you were an undergraduate student and something like that. If that sounds like you might be better suited for my other statistics class, which is Stats XL13. It's a faster paced class. Most of my students there already have their bachelor's degree, are applying to graduate programs. It's not a requirement to have taken calculus, but most of them took calculus at some point in time, kind of giving you an idea of where they stand mathematically. And so that class is taught at a little bit of a faster pace. We cover more material in statistics. It usually fulfills the same requirements that this class does in terms of graduate programs. So, so if that sounds like you might actually find yourself a little bit bored in this class, and the other class might be a better fit. Up to you. I know there's probably some students on the wait list who are looking to add. So so anyway, just wanted to throw that out there if you think you might be a better fit for my faster paced class. Okay. All right. So anyway, Stats XL10 Intro Statistics. A little bit about myself. I have my PhD in statistics. I absolutely love the subject of stats. I love teaching. I am always very excited to teach a new class because I know most of you are coming in here maybe not super excited about the course, but I'm hoping that at least by the end of the class, I have a mission to at least make you at least appreciate this subject matter, okay? And so, when I took my intro stats class as an undergraduate student, I didn't go to UCLA, but I wish I did. But when I took the undergraduate stats intro class, it changed my life. It literally changed my life, how I perceive the world and things like that. And so I went back to grad school here at UCLA, got my PhD, and now trying to make a career teaching statistics and getting you guys to, if not love the subject, at least kind of appreciate it, okay? And those of, many of you might call yourself math haters or just, I was never a math person or say something like that, but I think you can still appreciate the subject of statistics. So anyway, I'm going to just write I heart stats, and I hope you at least like it a little bit, okay? So anyway, and you guys are the paying customer. I am offering this product of education to you, and I want you guys to be satisfied with the product I'm offering or the service I'm offering. And so if there's anything that you are unsatisfied with, I'll do my best to make you a happy customer. Of course, within reason. If you're just going to demand that I give you an A, I can't do that. I do have a responsibility to the university also, that everybody who passes the class, I can say, understands statistics at some level. So, okay, so what is? Let's talk about this. Why do we study statistics? Okay. Okay, so why do we study statistics? Why do we go to college? Why do we go to school? And I argue that at the very heart of it is to help us understand the world around us. Okay. And this can be said about many subjects that you might study. And in particular, statistics, helps us understand the world by allowing us to make conclusions from limited data. Okay, so what do I mean by that? Okay, so let's say there's something you want to learn. Okay, want to know about the world, and it could just be a question like, does does using some drug, okay, cause long-term brain damage or something like that? Let's say you have this question. This is our research question. We want to This is what we want to know. Now, this is a tough question to answer. We might not be able to answer it directly, but we can do some studies, okay? Now, to properly answer this question, we would need to look at lots of people, have have lots of subjects, and say, have some people use the drug, some people not use the drug, and see if there's a difference in brain damage or whatnot between the two groups. Okay. Okay, and this would be take lots of people, okay, have some use the drug, and then have the others not avoid the drug. And then study the differences between the two groups. Okay. Is everybody able to see the screen and follow along okay? This is setup's working out for you guys? Okay. Okay, and so but this, this requires data, and even if you were able to conduct a, $1 million study and have lots of volunteers and the like, you actually don't have information about everybody, right? Because there are people who didn't volunteer for the experiment, and we want to know, well, would this drug affect these people? And so what statistics allow us to do is it allows us to make conclusions about people who didn't participate in the study, okay? So we're making general conclusions about what we call the population, which would be everybody possible, based on just the people who participated in our experiment, which we would consider limited data. Does that Make sense? Okay. Can I go to the next slide? Did everybody get this written down? I'm not hearing any objections, so here I go. Okay, and so this is the concept of inferential statistics. Okay, and that is making conclusions about the population based on a sample of data. Okay, so let's define the population. The population was everyone that is relevant to our research question. Okay, so that's everyone. Generally, the population is too big for us to study directly. Almost always too big Okay, otherwise, we would study the population if we could study it directly. Okay, but usually the population is too big for us to study directly. Okay, so we take a sample. Okay, a sample is a selection taken from the population. That we are able to observe. Okay. Ideally, our sample is representative of the population. Okay. That way, or I'll just say with a representative sample, conclusions made from the sample can be generalized to the population. So we can say, well, this happened in our sample. This is what we observed in our sample. Therefore, we're going to conclude that the population is similar or will behave in a similar way. Okay? And that only works if the sample is representative of the population. So for example, if if I were to ask you people, what percentage of you use a smartphone, okay? Probably almost 100% or 90-something% of you will say, I use a smartphone, okay? But you are not representative of the world or the United States even, okay? You are not representative. So I cannot then say, well, I surveyed my class of, college students, and they said this percentage use smartphones, therefore 90% of the world uses smartphones or something like that, okay? That doesn't work. You are not a representative sample of really any general demographic group, okay? So so we cannot take, so conclusions made from this class cannot be generalized to anything, okay? It can only just say, well, this is what happened in my class, and that's it, okay? Because I'm trying to think of what you guys could be representative of, but there's really nothing that you would truly represent. Yes?
Would we be representative of your other classes as your class?
I would, you know, of all, representative of all statistics classes that I have taught, I would say, you know, maybe, okay, but you know, it's different. You know, from quarter to quarter, I experience different amounts of variation. Some quarters I have lots of international students from Sweden, and other quarters I have hardly any. You know, some quarters I have lots of students from Glendale, and some other quarters I don't. You know, so it all depends, and so. You know, and I think people, you know, try to enroll with their friends and stuff like that, and so you're gonna get these kind of pockets of people that will make this one class not representative of, I would even just say, even all of my other classes that I've taught. So yeah, so I don't know, you know, that's just kind of how that goes. So but anyway, this is the concept, and so you know, here's a visual representation. This giant thing, it's supposed to be a large thing. This is the population, and you have to imagine there's, you know, tons of little dots, each dot representing a person, and you have to imagine, you know, millions or lots and lots and lots of people in the population, too many to observe directly. And all we're doing is we're just taking a small little thing called a sample, okay? And this is what we are studying, okay? So we study this. And based on what we see here, we want to generalize to the population. Okay. So don't shout out the answer, but I'm going to just ask you a question. See if you are paying attention, okay? But don't shout out the answer. Just think of the answer in your head. If we want to generalize the conclusions we make from the sample, if we want to generalize them to the population, what must be true about our sample? So don't shout it out, okay? So if we want the conclusions from the sample to be generalized to the population, what must be true about our sample? And the answer is the sample must be representative of the population. Okay, did you guys get that right? Okay, good. And if you got that wrong, at least highlight that in your notes and say this is an important concept, okay? We gather data, okay? And we often say that data can come in two forms, okay? Okay, one is numeric data. Also called quantitative data, this tells us this data tells us how much or how many we have of something. Okay, so examples are things like someone's height. Tells you how many inches tall someone is or how many centimeters tall someone is. Height, weight. Whatever, you know, sales figures. You know, how many, you know, shooting percentage on for basketball or whatever it might be, okay? And then we also have categorical data. Okay. This is also called qualitative. Tells us what type or what kind, or, you know, applies a label. To an observation. Okay, so some examples. Gender. You know, race, hair color, etc. So, you know, a lot of times I'll mention examples from the textbook. I'm looking at the second edition. So, second edition, page 7, example 1. You know, there's a table of data. And we're looking at different cars, okay? Whoops. So some vehicles. We have make, model, number of doors, the weight, and this is a head injury crash test result. Head injury rating. Okay, so we have, for example, the Acura Integra has 2 doors, weighs 2350. Head injury rating 599. Okay. So if we're going to apply labels, this would be, I can just write categorical, categorical, and this would be numeric, numeric, numeric. Okay? Is that good? Okay. So with we can summarize categorical data with counts and percentages, or which is the same thing as a proportion. And okay, so and we can summarize numeric data with numeric summaries is what I'll just call them. And I'll just do a few examples of numeric summaries. Numeric summaries like the mean and the median, or the standard deviation, etc., etc. Okay, and we'll cover many of these next week. Is this okay? Next slide, okay?
Yes.
Did someone say no? Okay, all right, I'll wait. Okay, I'm going to go on. We have, depending on what you're looking at, you know, data can be presented you know, in a few ways. And you know, if you don't go into a career in statistics, maybe this is not so important, but we prefer data to be presented in what we call the stacked form. Okay, this is what the book calls stacked. Okay. But basically, this means each row in a table is an observation and each column is a variable. So, for example, perhaps maybe let's see. So we got name, and maybe we'll say sex, and we'll put weight here. All right, and so we have Adam is male and weighs 182, and Beth is female and weighs 140, and Carl is male and weighs 155, and I don't know, Diane, female and weighs 120. Who knows? Okay, so we got this. All right, etc., etc., etc. More rows. Okay, this would be considered unstacked. Okay, each row is a person or an observation. Hope everyone's okay. And each column is a variable, all right? And what are the columns that we have? We have name, we have sex, and we have weight. Okay, and so name would be categorical, sex would be categorical, and weight would be numeric. Okay, we could present at least some of this data in what we call, oh, did I write unstacked? I meant to say stacked. That's my bad. Sorry, gonna confuse you guys.
What does it say in the parentheses?
Observation.
Oh,
It's right. Each row is a person observation. Here, I'll try to write more clearly here. It's tricky writing on a tablet here. Okay, is that better? Observation. Okay, and there's more rows here. Okay, the unstacked form. We might say we might put males and females over here, and we'll say the males, when we're looking at just weight info, we've got Adam who weighs 182 and Carl who weighs 155 and whatever more data we have, and then Beth weighs 140 and Diane weighs 120, etc., etc., etc. Something like that. Who knows? Okay. So this is considered unstacked, and here it's less obvious what our variables are. Okay. We still have two variables. Here we have two variables, and they are the sex, which is our column headings, and the weight, which is what we have in each cell. But these are, the variables are less obvious in unstacked form. And so, if you ever get data from the internet or something like that, sometimes the data is presented in an unstacked form, okay? And in that case, you're going to have to, you're probably going to want to turn it into the stacked form and work out that way, okay? Is that good? Okay. Yes?
Wait, unstacked pretty much not really much. There's not a lot of label, but stacked there is a lot of label.
I mean, we could allow a label. It is possible to say
How do you do
you would do it something like this. You'd say Adam 182, Carl 155. And it looks funny, but this is perfectly valid. It's not. There's nothing wrong with this. And you could label each of these numbers this way, and that would have a a third variable in here for including the name. But again, a lot of times stacked data, or I'm sorry, the unstacked form is kind of presented in tables and charts online because it kind of changes the form a little bit. Because a stacked data set, you're going to end up getting kind of if you can imagine having 100 people, okay, we're going to have kind of a long data set this way. Whereas when you unstack it, kind of as it implies, you're forming kind of a shorter pile of numbers, okay? Whereas with the stack, you're forming it all into one pile. And this is probably the preferred form, at least for data analysis. But in terms of presenting data, maybe it's not as pretty. And so a lot of times when you go online and you look at tables, you might see things in an unstacked form because it might be easier to present data that way. But it makes the analysis a little bit, in my opinion, less intuitive. But anyway, that's all I really need to say about that. Sure. All data sets should have some kind of context. Okay. So all data sets, basically a data set is data taken from a sample. Okay. And what is a sample again?
Representation of the population.
Not necessarily represent. It's a selection taken from the population. We're hoping it's representative of the population, okay? But it's a selection taken from the population that we can observe. Okay, so whenever you have data, it's coming from a sample that you have observed. The population is just this large entity, too big for us to observe directly. Okay, so all data sets will have some kind of context. Which is very important. The conclusions you make from one data set might have very different implications than from another data set. Okay? If we look at internet search results, let's say Google shared all of their data, and we looked at internet searches from this year. The conclusions we make from the internet searches this year would be very different from the conclusions we make from the internet searches made, a year ago or 10 years ago. Okay, just because things are very different, right? If you go back 20 years, searches for, well, I don't know how many internet searches there were, but if you searched for Paris Hilton 20 years ago, your results will probably be a hotel in Paris, right? Whereas today, you get something about a person. So the context, when the data was taken, why the data or how the data was collected, all of that, everything, you learned your 5W questions, right? 5 W's and the H. You guys all learned these like in grade school. These questions, these all play. You're supposed to include these things when writing a story or setting up a story or something. Same idea. You figure data has some kind of story to tell, and it matters. Okay, so these are key elements to a story. And likewise, they are also key elements in providing some background or context to our data. This is covered a little bit in more detail in the textbook, so do your reading this week. We'll do that. Okay, so let's talk about summarizing categorical data Okay, so do you guys remember what I said? How can we summarize categorical data? With counts and percentages. Okay. Okay. Summarize. So we can summarize with counts and with percentages or proportions. Okay. Another word for counts, also called frequencies. And percentages are also proportions. Okay. So proportions generally go from 0 to 1, and percentages go from 0% to 100%. Essentially, they're the exact same thing. You just move the decimal over 2 spaces to the left or right, depending which direction we're going, right? And I'm assuming you all know all of this, right? Okay, and so so think of raw data and we can ask people, you know, maybe we don't even care what their name is, but we can ask something like we've just got, you know, I'm just going to label them person 1, person 2, person 3. Essentially, these are row, just row numbers. Okay, so this I wouldn't even say is a variable. And let's say the only variable we're asking is your gender, okay, or your sex. Okay, so person 1, let's say, is female. Person 2 is female. Person 3 is male. Person 4 is female. Person 5 is male. Okay. So let's say this is your entire data set. Okay, you surveyed 5 random people, and this is what you get. Okay? How can we summarize this? Okay, so we're going to summarize this with, yeah, so these are all sorts of things we can say, okay? So we can just summarize this with what we call a frequency table, or it's basically a table of counts. Frequency table, this is just the name of what this is, and all we say is we look at female and we look at male, and how many, the count or frequency, depending on what, you know, what label they decided to use. How many females do we have? 3 and 2 males, right? And optional, you might have a total row that says you looked at 5 people total, okay? So we've got that. So that's frequency table. Again, you can summarize with a percentage or a proportion, okay? And if you do that, then it becomes a relative frequency table. Now, some might do percentages only, or some, you know, you might have all 3 columns, okay? So we could do sex, and we've got percentage. And you've got female, male, and you've got 60%, 40%, okay? Now, how did I get 60 and 40%? You know, this should be obvious, but I just did. There were 3 females divided by 5 people total, and that's how we get 60%. Okay, so is that okay with everybody? Okay, so this, when you use a percentage, this is called a relative frequency table. Okay. Okay, so if my table says 60% female, 40% male, is the data I have numeric or categorical? It's categorical, okay? I just said we're summarizing categorical data, okay? Just because we got numbers here, right? We've got, you know, people think, oh, well, look, I've got numbers, it's numeric. No, this is categorical, right? We're asking, you have to think of the underlying raw data table. You might not see this, right? The reason why we create summary tables is so we don't have to present all the raw data table, right? You might have surveyed 500 people, and people don't care the individual numbers in the 500. They just want a summary, okay? So it might say, oh, 60% are female and 40% are male. This is still categorical data. Even though I'm summarizing it with a number, still we've got categorical data, okay? So don't confuse yourself there. This is categorical, okay? Question?
What about the mass of planets versus would you consider that to be categorical or
The mass?
mass?
Yeah, so mass, like weight of something, or you know, the amount of matter in grams, that would be numeric, okay? If we can talk about the raw data table, and that would be recorded in numbers. We wouldn't, unless you say lots of mass and little mass, or you know, I'm imagining you'd be using numbers there. But just think of how the raw data is collected. And here we're putting categories, right? Female or male, you know, if we say those are the only two options. Yeah, and life is more complicated than that. But
We do it like the planets or the mass of the planet, so that's why I said.
correct, and that would be a numeric variable, and so that would be something else. We'll cover numeric variables and summaries for numeric variables next week. But yeah, for right now, we're talking about categorical data, and we've got things like this, and it can be summarized with a frequency table or a relative frequency table, or you might have, you know, I'm just going to throw on, you know, maybe it'll say percentage right here, and you've got 60% and 40%. This is also allowed to put both the count and the percentage there or something, okay? So that's that. If you have, let's say you have two variables, let's say we can also create something called a two-way table. So let's say we've got my raw data table, and so we've got, you know, person 1, 2, 3, 4, 5. Let's say we have 6 people, and we'll say we got female, male, 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 female, male. Okay, and then maybe we asked, what's another categorical variable that we could apply? So we've got the sex of someone, and maybe we'll say, do you like... huh? Okay, well, eye color, there's so many, so, okay, well, okay, here. We'll just say, do you wear glasses? Okay? And this person says yes, this person says yes, and these people say no, 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 and yes, or something like that, okay? Who knows? I'm just making stuff up. Okay, so we've got two categorical variables, right? Okay, and so to summarize this, we're going to summarize this with what's called a two-way table or two-way frequency table. So the word frequency might be optional in this. Okay, and so here, what do we have? We have I would list off sex over here, and I've got female versus male. And then over here I would have glasses, and we have yes and no. Okay. If it's a yes/no question, something like, do you wear glasses? We could even turn sex into a yes/no question. You know, are you male? Yes or no. Or are you female? Yes or no. We could turn certain things can be turned into yes or no questions. Sometimes the yes or no's, rather than writing Y and N, it's recorded as 1 or 0. Usually 1 means yes and 0 means no, and that's just because computers like numbers more than letters. But it's all the same information. Okay, so don't be confused if you see the answer to a yes/no question turned into 1s and 0s. It still would be considered a categorical variable. Is that okay? All right, so with glasses, how many females wear glasses? 1, right? And how many females don't wear glasses? 1, okay. And how many males wear glasses? 2. And males that don't wear glasses, 2. Oh, this didn't turn out. Let me throw in a 7th person just so I don't have the same things here. Let's say the 7th person is a male who does not wear glasses. Okay, so then I would have 3 males without glasses. Okay, so at least I have some different numbers here. Okay, so I have a total of 3 people who wear glasses and a total of 4 people who don't wear glasses, a total of 5 males and 2 females, and I have a total of 7 people. Is this okay? Okay, so let me ask a few questions related to this, and let's just make sure our question understanding is all the same here. Okay, let's start a new slide. Okay, so far this is okay with everybody? Okay. So let me ask, what percent of people surveyed are female? Okay. Okay, so what operation would I do here? What fraction would I turn into a percentage? What percentage are female? 2 over 7, which would be like 28%, right? So I do 2 divided by 7, 0.28, okay, 0.286, or 28.6%. Okay, I could ask, what percent of females wear glasses? And what is the answer there? 1 out of 2, right? Percentage of females. So how many females are there? We've got 2 females. And of those, one of them wears glasses. So 1 out of 2, 50%. Yeah? And this is also different from asking what percent of glasses wearers are female. Yes?
Are these the kind of questions that will be like on a quiz?
Yeah, maybe. Okay, so you've got some questions on your practice quiz, kind of like this, and I think these would be fair to put on a quiz. Okay, so what percentage of glasses wearers are female? So how many glasses wearers do we have? We've got 3, and how many of those are female? 1. So this becomes 33.333%. Something like that. Am I losing anybody here? We're all good?
Wait, how are you most still if there's, I might be getting this wrong, but out of 3 of glasses.
Yeah, of glasses wearers. So how many people wear glasses? 3 wear glasses. Of those, how many are female? 1. Okay, what else do we have? Okay, and you know, what percent of those surveyed are females that wear glasses? Okay, so what goes in my denominator? How many people did I survey? A total of 7, and how many are females that wear glasses? 1, so I have something like 14.3. Or I don't know, what is it? 1 over 7, yeah, 14.3%. Is that okay? Going from the raw data to the summary table, the two-way summary table, and then answering questions based on the two-way summary table. Okay. Again, what kind of data do we have here? No. The summary table. What were summary? Numeric, categorical. What do we got? Categorical data, right? Okay. We got numbers, and we're using percentages, but it's categorical data because if we look at the raw data, they're categories. What sex are you? Do you wear glasses? Yes or no? Okay, that's categorical data. Okay, why don't we take a short break? It's 8:40. Let's take a 10-minute break. We'll come back at 8:50 and finish out our lecture there.